Hello everyone, welcome to this session. My name is Kalol Basu. Today we are going to talk about VxLAN with BGP EVPN on iOS XE platforms. As you know that this is not so old technology, this is fairly new and this is being widely deployed by many customers. So earlier it was popular in the data center. Nowadays it is being deployed even on the campus network. People are trying to implement that. So the agenda of the session is to talk briefly about how VxLAN with BGP VPN works. Then we are gonna take a look at the lab part. So we will spend most of the time on the lab. We will build the VxLAN from the scratch. We will take a look at the unicast configuration. We will take a look at the multicast. So basically whatever we need in the underlay, and then we will build the VxLAN configuration on top of it. So we will take a look at how the layer 2 VNI works. We will see how layer 3 VNI works, and finally we will also take a look at how you can make your VxLAN talk to the IP network. So all these three scenarios we will cover. To begin with, let's first try to understand what is VxLAN. VxLAN is basically it's a technology which helps you to extend the layer 2 over the layer 3. It also has a few other advantages. Say for example, you can do mobility. If you have a server which is connected to switch 1, and if you move the server to switch 2, then not necessarily you will need to change the IP address, or you need to change the gateway address information, even though there is no trunk link between the two switches. So it's basically you are carrying the layer 2 information over the layer 3 network. It's similar to what we have in OTV, but still not same, because in case of OTV you bring up you do that thing between the two sides. So you form the tunnel between the two sides. But in this case, it is more granular. So here you build the tunnels between the switches. Even though they're in the same data center, you can build the tunnel between the two switches to carry your layer 2 information over the layer 3. So if I draw a quick diagram, let's say that this is your switch 1, this is your switch 2, and this is your switch number 3. You have a host connected here, you have a host connected here, and you have a host connected here. Let's say this is in VLAN 10, this is also in VLAN 10, and this is in VLAN 20. Now, in the traditional network, if you wanted to make this VLAN 10 from this server switch number 1 to VLAN 10 in switch number 2 to work, to communicate, you had to extend your layer 2 using a trunk configuration, right? But the problem with the trunk is you have to rely on the spanning tree. In the spanning tree, we know that you cannot use all the links, because spanning tree is going to block one of the link, the redundant link, in the because of the loop prevention thing, right? You cannot utilize that. Plus, when you extend the layer to using the spanning tree, then if any failure happens, you need to consider the convergence time. Even though we have RSTP kind of features which helps minimizing the convergence time, but still you have to spend some time on that, right? This is not as fast as you can get over a routed link. Plus, if there is a chance of a bridging loop, sometimes you might want to avoid all these kind of things with the new design, what we are talking about. So what we do in VxLAN scenarios is we have a IP network. Let's say that this is your router 1 and this is your router 2. Okay, and you have connectivity between all the switches to both these routers here. So this is like a spinal leaf topology, right? So all the switches down the line, they are connected to these routers. And now you do not have any spanning tree here. This is running complete layer 3. So if you want to reach from one switch to another switch, this is basically a one hop away, 2 hops away, and you have two paths, and it is always through, always going to be ECMP, right? You can either reach, let me take another color. So you can either reach this way, or you can reach this way, right? So you can load balance. This is more of a ECMP path you have, and the advantage is you do not have a spanning tree. You do not need to extend your layer 2 broadcast domain. However, you are still able to extend your layer 2 over the layer 3 network, right? Now, also with this scenarios, you also get the advantage of mobility. You can move your server between the switches without even worrying about extending the layer 2. As long as you have IP connectivity and you have the right configuration to extend your fabric, you are okay to move your servers between the switches here. Why VxLAN? As I talked about that in the spanning tree time in the spanning tree network, you have quite a few disadvantages of extending your broadcast domain, of extending your layer 2 over the trunk link. That's something we are trying to overcome using this new kind of topology, using this new kind of design. Not necessarily you will have two routers here. You can manage with even one router. It's not a hard rule that you will have to have two routers. As long as you have some sort of IP connectivity, you are good. The reason we talked about this routers here because of mostly for redundancy purpose, the two routers. Okay. Now, expanded VLAN namespace. What we have in a traditional network is we use the VLAN, and the number of VLAN is, we know, 4096. That's the maximum color. That's the maximum number of VLAN what we get, 124096. Now, the problem what you encounter is, if this is one spanning tree domain, then if you have a customer here in VLAN 10 and you have another customer who is also trying to connect to your network but on a different switch, you cannot assign the VLAN 10 number to that particular client. So if this is, let's say, client number 1 who wants to talk using VLAN number 10 and it is connected to switch number 1, you cannot assign the same VLAN to a different client who is now connected to switch number 2, because the VLAN number is globally significant here in the entire layer 2 domain, right? With the VxLAN, you have 16 million numbers. So this is pretty much close to infinite. You cannot probably exhaust those number of VNIs. Okay, we will talk about that. What are the VNIs? But you have 16 million number, and what you can do is, if you have VLAN 10 here for customer A, say for example, and you have another customer who is in switch number 2 or switch number 3, if they also want to use VLAN 10, it's perfectly fine to configure VLAN 10 there, because the VLAN number is now only locally significant. Now, locally significant to this particular switches, right? And when you extend your layer 2 over the layer 3, then that VLAN number is not carried anyway. there is a new number, which is a VNI number, which we will talk about. So that number is going to be globally significant. And using that number, you can manage your broadcast network. And that way you can basically uh, get rid of this limitation of only 4096 VLANs, what you have in traditional spanning tree. So the space of the number of VNIs are huge. You probably cannot exhaust that in your data center. Layer 2 multipath, as we just talked about, that you can load balance, you can do ECMP. You don't need to worry about spanning to convergence time anymore. You don't need to worry about any bridging loop. As long as you have IP connectivity and if it is ECMP, then it's fairly easy to manage. Scaling enhancements for bump traffic. Bump stands for broadcast, unknown unicast, and multicast. Bump traffic, MAC learning, and control plane optimization. So what we had in the spanning tree is if it was a trunk link between switch number 1, 2, and 3, even though your, let's say for example, switch number 3, it doesn't have any VLAN number 10 configured here, right? But typically if you have VLAN number 10 globally defined, right, on the switch, and if you configure trunk, then the broadcast is going to be there all the time, right? It is going to be forwarded all the time. Yes, you could do VTP pruning as well, but it has its own limitations. Now, in the EVPN scenario, in the VxLAN scenario, what we can do is we can send the broadcast only to a specific group, multicast group address, and whoever is interested to listen to that particular broadcast range, they can join that particular multicast group and they can receive the traffic. And all the others you do not need to send the traffic to. So basically you do not flood it. You flood, but it's not a broadcast, it's kind of a multicast. So you that way you can limit it. Plus the MAC learning and the control plane optimization is when we are doing the VxLAN with EVPN, you basically do not learn the MAC in your show MAC address table anymore. It does get into the hardware, but eventually you do not learn it in the show MAC address table. You learn the MAC addresses over the BGP routes. We will talk about that in detail, how it is happening. So don't worry about it. But as of now, you can think about your MAC addresses are automatically learned as a BGP route, like what we have seen in OTV, that your MAC addresses of the remote sites are learned as a ISIS route. So in this solution, it is learned as a BGP EVPN routes, and then you know that your switch knows that which MAC belongs to which switch address. We call it a VTEP. We will talk about this in the next slide. So basically it knows the mapping, which host is connected behind which switch, and whenever it will need to send the traffic, it will basically encapsulate the packet in that particular unicast header and to destined to that particular destination switch, and then from here that switch will deliver the packet to the destination host. So that's pretty much how it works. And whenever a client is coming online, your whenever the ARP cache is going to be populated, your BGP is going to offload that, and it is going to make everyone aware of that. Now, in the spanning tree world, if let's say that your switch 2 has a host coming online, switch 1 will not know about that unless switch number 2 or unless switch number 1 it has any device connected to switch number 1 which is trying to talk to switch number 2, and then switch number 1 is learning the MAC address of that end client here, right? By default, my switch number 1 won't be knowing about this MAC address. But in case of a BGP EVPN control plane, this is not the data plane learning we are doing. This is not the flood and learn. Whenever the host comes online, if it is not a silent host, then you are expecting that route to be advertised to the BGP and reaching out to your switches here who are basically in the same VNI, right? So that way they will already be knowing that which host is behind which switch, and they no need to flood that unnecessarily. So that way you can reduce it. If the MAC address, if the host is unknown for some reason, then yes, it can always use the flooding mechanism as we talked about. It uses the multicast, and it can learn about the host location. It supports layer 2 adjacency vMotion, what we talked about. If you want to move the server from one switch to another switch, you can do it without changing the IP address or anything, as we talked about. Segmentation, which is a very important thing. In case of a VLAN, of course, the VLAN numbers are segmentations. You are keeping the traffic separate. Even for layer 3, if you have multiple customers, you can do the segmentation pretty easily, and you can still manage that over the IP network. You can make sure that your traffic for one customer is kept separate from the other customer. Okay, let's take a look at the VxLAN terminologies. The first is underlay and the overlay. If we draw this quick diagram once more, these are the two spined routers, okay? And you have all these leaf switches here, down here. And you have all the hosts connected here. So these are the hosts. And all the switches are basically connected to both the routers. And this is IP network. Okay. What do we mean by underlay here is you need to make sure that you have connectivity between all these leaf switches here. This is switch number 1, switch number 2, and switch number 3. We will configure that in the next slide. We will take a look at that, how to configure it, how to make sure we have the reachability. But just to let you know, just to make you understand that in order to make VxLAN work, you have to make sure that all the switches 1, 2, and 3, they can reach each other. We will need to use a source interface for any tunnel, right, as you know. So in this case also we will be using a source interface. We will prefer using loopback 0, and then you have to make sure that the loopback 0 is reachable between the switches. So that's the underlay. On top of it, you also need to make sure that you have multicast working perfectly fine, because as we just talked about in the previous slide, in case if any of the host is not known and the switch needs to flood it, it needs to send the multicast traffic. So if your multicast in the IP network is not working properly, then the solution is not going to work. In the VxLAN, you can do flood and learning as well. There are two modes, the data plane learning and the control plane learning. But the data plane learning is not efficient. Plus, we do not support that on the catalyst switches that I'm talking about. You can do it on the Nexus, but not on the catalyst. So you have to do EVPN control plane, which will help the switches to learn the control plane information. And for that, you need to have the multicast working in the underlay. So that's a hard requirement. You have to have your multicast working perfectly fine. In the underlay, you can use any kind of IGP. There is no specific guideline. You have to use OSPF or EdgeRP. You can use anything. You can do static routing. You can do OSPF, EdgeRP. It's up to you. PIM is something which will take care of the multicast routing in the underlay. In the overlay, we are going to use the VxLAN, the BGP EVPN. BGP EVPN is basically going to help with the control plane. EVPN is the address family. You know about BGP VPN before address family, or L2 VPN VPLS address family. So EVPN is another address family which helps us with this particular solution. Okay. Next, talk about the VNIs. VNIs are basically the replacement of your VLAN number in this part of it. So the customers are still, sending the traffic, and you were receiving the traffic in the VLAN, the traditional VLAN number. But when the traffic is going here in the IP network, then you don't have the VLAN number anymore. In that case, the VLAN number is thrown away, and then you put a mapping between the VLAN and the VNI on all the switches here. Okay, and that VNI number is basically attached to your packet. We will look at the packet format, how the encapsulation is done, but this is what VNI is. It is basically a number, and that number is pretty huge. It's a 24 bits number, close to 16 million. VTEP. This is virtual tunnel endpoint. All the switches I'm talking about where your host is connected to, we call them VTEP. So in a nutshell, you need to make sure that before you configure the VxLAN, you have end-to-end reachability between all the VTEPs. Like for MPLS VPN scenario, what you do is you make sure that your Ps have the reachability and you configure route reflector in between to make sure that your all the Ps can talk to each other, because most of the time you cannot have a full mesh. You make sure that you do a route reflector to have the reachability. Here also we do a similar kind of thing. This is not a VPN scenario, but you still need to make sure that all the VTEPs, this is kind of a P in your MPLS VPN scenario. So these are the VTEPs which need to have the reachability within themselves, right, in the internal network. And then these routers, what we're talking about, we can configure them as route reflector for the BGP, which can reflect the EVPN routes from one VTEP to another VTEP. VxLAN segment layer 2 overlay network. So in the VNI, we can actually separate the broadcast domain by using the VNI. So one VNI is one broadcast domain. There is no VLAN number there. And we will take a look how to configure that and how the VLAN 10 client in switch number 1, VTEP 1, can talk to another VLAN 10 client in switch number 2. We will take a look at that. And then VxLAN gateway. For forwarding the traffic between the VxLAN. So if you have a client in VLAN 10 and if you have another client in VLAN 10, right, the same customer but two different hosts, then how can you make them communicate? If they are in the same switches, then yes, VLAN 10 to VLAN 20 you can do the routing. But if you have VLAN 10 here, you don't have VLAN 20, and if this guy has only VLAN 20 here and they don't have VLAN 10, then by default that layer 3 communications between 10 and 20 won't work. In that case, you need to have a router who is going to routing the packet between them, and we will talk about that. In this particular solution, you do not need to have a separate router to do that. You can do it on the local VTEP itself, but we need to use a layer 3 VNI for that, and we will talk about integrated routing bridging, IRB, that how we can achieve that. Next is Network Virtualization Edge, or NVE. This is nothing but your overlay interface. So in OTV, we talked about the overlay interface. Let's say, for example, overlay 1, interface overlay 1, or even for GRE, we do interface tunnel 0. In this case, it is the interface name is interface NVE, which is Network Virtualization Edge. Then you give a number, and then you configure the overlay on top of it. Next is VxLAN encapsulation. This is how a packet frame looks like. This is your host, end host is sending the traffic. This is an ICMP packet. On top of it, you have the IP header, and on top of it, you have the Ethernet header. So this is basically what is coming from your end client. Now, what the VTEP does, when the VTEP is trying to send the packet to other VTEP through the tunnel, it is going to add a VxLAN header. This VxLAN header is basically consisting of a VNI number, and the VNI number is something which you map manually to each of the VLANs. After that, it is adding a UDP header. The UDP header is the transport which is being used, and it is also helping to hash the traffic over multiple links to load balance the traffic. You have a specific destination port that you use 4789 for the data plane, but the source port is random. And this is the source port which you use to hash your traffic to multiple ECMP load balanced links. After that, you have the IP header. This is basically the encapsulation which is happening. In this IP header, you have the source IP of your source VTEP and the destination IP of your destination VTEP, right? If your packet is leaving from VTEP 1 to VTEP 2, then this IP will be the IP of the VTEP 1. and this IP will be the IP of VTIP number 2. And that is the reason it is very important to have the reachability between all the VTIPs, what we just talked about in the previous slide. So in the underlay, you must have to have the reachability of that. And the last part is a Ethernet header. This is basically the Ethernet header for the routed traffic, for normal routed traffic what you have. If you want to route the traffic between the VTIP 1 and VTIP 2, whatever Ethernet MAC address should be there, this is what you should see here. So in case if it is routed over the route reflector, what we have seen in your previous small diagram, then the source MAC address would be the VTIP 1's MAC address, and the destination would be the next hop L3 device's MAC address, which is the route reflector or any other device in your case. That's pretty much how the VxLAN encapsulation looks like. Then we will see how the remote VTIPs are discovered. We touched on that briefly in the previous slide, that you can do it in two different ways. You can do through multicast flood and learning, which is what we just talked about, right? If it is data plane flood and learning, then that's not efficient and you cannot do it on the catalyst switches. But we can do multicast flood and learning. So in case if a client is sending a packet for a destination, which or MAC address, which you don't know, the VTIP doesn't know, it is going to send the packet to a multicast address. Which multicast address and how it will send it, we will talk about that. But it will send the packet to a multicast address, and whoever other VTIPs are also listening to that group, they will receive the traffic and they will do the needful. So this is how the flooding is happening in this VxLAN EVPN scenario. The ingress replication is basically what you do is, if you don't use multicast, then you will need to replicate the traffic, do the hidden replication, and you have to send each copy of the packet to all the VTIPs. So you have to send one copy to VTIP 2, one copy to VTIP 3. But think about it, if you have 100 VTIP switches in your network, this is going to be a nightmare. So you don't really do that. And that's the reason it is very important to have the multicast working and to make sure that you are doing the flooding using the multicast if you need to flood. And finally, the control plane, which is the BGP EVPN. This is going to pretty much eliminate the need of broadcast in multicast in most of the cases, because your control plane would already be built in as soon as any host comes online. So likely you don't need to flood too much. As soon as your host comes online, your BGP VPN should be able to build that, should be able to know about that, and it would advertise that prefix to all the VTIPs, right? So that way they don't need to flood. So pretty much that's all we have from this theory perspective, nothing much. We will take a look at the lab, which we will now explore. And in the lab, we are going to build it, the underlay first, and then we will take a look at the VxLAN overlay. We will take a look at all the layer 2 VNI, layer 3 VNIs. We will take a look at the VxLAN to IP network communication. So in the lab, we have this 1, 2, 3, 4, and 5. There's 5 switches here. Out of that, this particular one second, this one here, this is basically your VTIP 1. This is going to be my route reflector. Okay, this is going to be my VTIP 2. This is going to be my VTIP 3, and this is going to be my VTIP 4. What we will do is, we will first, in the next session, we will configure the underlay. We will make sure that everything is good to go, and then we will move into the VxLAN L2 VNI configuration. These are the clients here. This is in VLAN 10, as you can see here. I have a client here who is in both VLAN 10 and VLAN 20, and there is a client here which is in only VLAN 20. And this client that you see here, this is basically the external network, and we will see that how that works with VxLAN, how we can make the communication happening between the VxLAN network and the IP network. We will talk about that. All right, that being said, that's all for this particular session. We will come back with the next session with the demo on the lab, and we will build each component, and we will explain all the things in detail to make you understand how the solution works end to end. Thank you for your time. Thank you. Take care.